Hi, and welcome to Mr. Garofolo's podcast. In today's episode, we're looking at example 5 from your classwork problems in the packet titled More Solving of Quadratic Equations. As we learned in class today, there's a couple of ways to solve quadratic equations. We start out by solving them by using factoring techniques. So I'd like to review that process in this problem to start. This problem asks us to solve x minus 2 squared is equal to 25. Now remember, when we're solving by factoring, we want to get the equation in the standard form for a quadratic. That would be ax squared plus bx plus c is equal to 0, where this is the quadratic term, this is the linear term, and this is the constant term. In order to accomplish that, I'm going to have to evaluate or expand this binomial that's being raised to the second power. When I do that multiplication, the result will be a trinomial. X squared minus 4x plus 4 is equal to 25. If you're unsure how I got that, just think x minus 2 times x minus 2 and double distribute. So now I see I have a squared term here, so I have a quadratic term, but the constant 25 should be on the left side of the equation, and right now it's on the right side of the equation. So to accomplish the goal of getting all the terms on the left, I'll be moving 25 to the left side of the equation by subtracting it from both sides. This will give us a value of 0 on the right side, and on the left side we will have x squared minus 4x minus 21. So now we're finally at the point where we're in standard form. Now we can start applying some factoring techniques to the expression that we have set equal to 0. I always look for GCF first. Say the coefficient of the leading term is a 1, so the GCF for coefficients will only be a 1, and not all the terms have an x. So GCF is not going to be a technique that will work. This is not the difference of two squares. We have 3 terms, and only one of them is actually a perfect square. So we're going to use our trinomial factoring techniques. We need a product of negative 21 and a sum of negative 4. And the numbers that will accomplish that are negative 7 and positive 3. So this would be x minus 7 times x plus 3. So now that we see we have, in factored form, two expressions that when multiplied equal 0, we want to apply the zero product property. That means we'll be setting each factor equal to 0. So x minus 7 is equal to x plus 7. Oh, I made a mistake there. Let me go back and correct that. X minus 7 is equal to 0, or x plus 3 is equal to 0. That would mean that x is either equal to 7 or x is equal to negative 3. So our solution set, negative 3, 7. And as always, we'd want to go and substitute these back in just to verify our solution, do our checks. So I'll take 7 first, which would be 7 minus 2 squared equals 25. 7 minus 2 is 5, and 5 squared is 25. So that checks. And negative 3 minus 2 squared equal to 25. That would be negative 5 squared is equal to 25, and negative 5 squared is also 25. So we have verified those solutions. As we were discussing in class, there is an alternate way to do some of these types of problems, and that would be by using square roots. So I'd like to take a look at that now. Before we do that, I'd like us to think about a couple of ideas first. Let's say we had a perfect square, say 16, and we were asked to take the square root of 16. We would note the square root of 16 is equal to 4, and in the case of quadratics, we need to use both positive and negative roots. So we would say 4 or negative 4, or plus or minus 4. Well, what What about if I use the square root symbol, but instead of 16, I wrote 4 squared? Would the square root still be 4? Well, let's think about it. If I squared 4, I'm still going to get 16. And if I take the square root of 16, I'm still going to get plus or minus 4. So let's apply this to another example. Let's say the square root of 25. Is the square root of 25 equal to the square root of 5 squared? Well, the square root of 25 plus or minus 5. 5 squared is 25, and the square root of 25 is plus or minus 5. So yes. Well, why is this so important? Well, we have to think about the expression that we're dealing with on this problem. Here we're given x minus 2 squared is equal to 25. So let's think about what that means. X minus 2 squared is x squared minus 4x plus 4. That means when we take x minus 2 and multiply it by itself, we get this trinomial. Do you remember last week when I was asking you to make a note of perfect square trinomials? Well, here's one of the reasons I was asking you to do that. This trinomial, this product, as a result of squaring a binomial, is a perfect square trinomial. That means if we took the square root of x squared minus 4x plus 4, it would have to be equal to x minus 2, since x minus 2 times itself gives us that trinomial. Now let's go back to the idea from earlier. The square root of 16 and the square root of 4 squared were the same. The square root of 25 and the square root of 5 squared were the same. Well, what would happen if instead of taking the square root of x squared minus 4x plus 4, I said, hey, let's take the square root of x minus 2 squared? What would be its square root? Well, remember, when we evaluate this, we get this expression. That means its square root, you guessed it, must be x minus 2. So why am I going through all this? Well, let's go back to that previous example. I want to apply that to this problem. When I see a binomial being raised to the second power, I know the result is going to be a perfect square trinomial, of which I'm going to be able to take its square root. So I'm not going to bother evaluating it to get to this expression. I'm simply going to take the square root. And if I do it on one side, I've got to do it on both sides. So the square root of x minus 2 squared is x minus 2. The square root of 25 is plus or minus 5. Right? Since negative 5 squared is 25 and 5 squared is 25. So we have the following equation. X minus 2 is equal to plus or minus 5. So I'm going to rewrite them separately. X minus 2 is equal to positive 5, or x minus 2 is equal to negative 5. Now we solve each of these. And watch how these solutions will match up with our solutions from the left-hand side. 5 plus 2 is 7, so x equals 7. Or add 2 to both sides here. Negative 5 plus 2 is negative 3. Well, look at that. Those are the solutions we had by doing it by factoring. Okay, so the right side here, if you wanted to give it a name, is really solving by inverse operations. The left side is solving by factoring. Let's take a look at the next example, which has a fraction in it. The one thing that jumps out to me right away in this problem is I see I have a binomial squared. I know if I evaluate this, I'm going to get a perfect square trinomial for which I can take the square root. But before I do that, I would love to get rid of this fraction. So we're going to multiply both sides by that denominator, 3. That'll leave us with x minus 4 to the second power is equal to 36. Now that jumps out at me right away. 36, I'm thinking, yes, 36 is a perfect square. And I know if I evaluate x minus 4 to the second power, I'm going to get a perfect square. So at this point, this seems like a nice problem to use the square root method on. We take the square root of x minus 4 squared. It's going to be x minus 4. The square root of 36 would be plus or minus 6. And now I'm going to write two equations out of that. X minus 4 equals 6, or x minus 4 is equal to negative 6. Solve each equation. Add 4 to both sides here. One solution is 10. Add 4 to both sides here. Or x is equal to negative 2. Let's check our solutions. We'll go back into the original equation. Our first solution was 10. 10 minus 4 squared divided by 3 equals 12. Well, 10 minus 4 would be 6. So 6 squared divided by 3 equals 12. 6 squared is 36. 36 divided by 3 is in fact 12. So 10 checks. Let's check negative 2. Negative 2 minus 4 squared divided by 3 is equal to 12. Negative 2 minus 4 would become negative 6 squared over 3 equals 12. Negative 6 squared is 36. 36 divided by 3 is 12. There we have it. Both solutions checked. Ultimately, if you're not comfortable yet with this idea of taking the square root, you can still go ahead and evaluate that expression. In other words, after you multiplied by 3, I'm just going to work this down here. After we multiplied by 3, we were left with x minus 4 squared is equal to 36. You can still solve this one by factoring. You're going to have to multiply out x minus 4 squared. You're going to have to write it in what's called expanded form. It would come out to be x squared minus 8x plus 16 equals 36. Then from there, you would have to move 36 to the left side of the equation. You would have to factor, tee it up, solve, just as we've been doing. Well, I hope this podcast was helpful. Please send me an email if you have any questions, and I'll see you in class.